Now, to use public key cryptography to actually exchange keys securely, we have to get a little bit more complex because we have to introduce a third party. And that's going to be our certificate authority that we trust. So what we have to do is we have to agree on an authority that has a private key that we trust. And so let's say that I am the client. I have pre-distributed the public key for the CA. And similarly, we have a server, and the server has the public key for the CA. And so what the server does is before it gets set up or runs, it goes and says, here is my public key. And I would like you to sign or verify that this really is mine. And the CA returns a sort of digital signature or certificate validating the authenticity. Now, rather than going deep into the details of how this works, basically what the CA is doing is it's using its private key. It's encrypting the server's public key and the address, the URL of this server. So if this is foo.com and it wants to get a key, it's going to send foo.com or its domain and the public key to the certificate authority. The certificate authority is going to encrypt both of those pieces of data using its private key, or basically put them into the box using its private key, and then it's going to send the box back to the server. Now, anytime the server needs to get its public key and the domain that it's running on to a client so that the client can verify the authenticity of its certificate or of a key, it basically sends, and we're going to call this the box. This is really a certificate, but to keep going with the analogy that we used before, we're going to call this the box. So we sent the public key and the domain, something like foo.com, to the certificate authority. The certificate authority took both of those pieces of data and put them into this secure box and locked them using its private key. Now, the certificate authority sends them both back to the server. It sends the box back to the server. And now, whenever the server needs to give its key to a client to communicate with it, in this case, give it its public key, the server sends that box that has the public key in it for the server. And the client can guarantee and check that nobody has intercepted, and this also has the domain, by the way. So in this case, it would be foo.com. The client can use the public key that it already has for the certificate authority, which it trusts. It can unlock the box, take the public key out, look at the domain, and say, yes, this public key is attached to this domain. And so if it's trying to communicate with foo.com, it can unlock the box and see that foo.com is in the box as well as the public key that should be associated with foo.com. And then the client knows I can use that public key to communicate with the foo.com server in order to send it data that nobody else can intercept. And essentially what the client and the server do is they use this public key in this initial conversation to set up a key and a secure communication channel. The public and private keys are not continually used from that point of view. They actually are used to set up additional encryption information and start a session. But this initial startup of the session, this bootstrapping, is done through public key encryption. So this happens one time at the setup of this server. So when foo.com decides, I want to be able to allow my clients to connect to me in a secure way, they go and send a request to the certificate authority to get their public key attached to their domain, and they get that box back or that certificate back from the certificate authority. And they do that once. And then whenever any new client comes and connects, they just keep sending that box back with their public key and their domain. And the client, whenever it wants, or whenever it gets this thing, because it should be doing it every time, can unlock the box with the public key to verify that this is the correct public key for foo.com. If an attacker gets in the middle here and they try to send a different box back to the client, when the client tries to go and unlock that other box that the attacker substituted with the public key of the certificate authority, it's not going to unlock. And the client will detect that they received a box or a certificate that wasn't the proper one from somebody in the middle. So the public and private key system allows the client to detect and verify that the key that it's about to use to communicate with the server to set up this secure session really is the key that's supposed to be associated with that session. And the way it does it is by using the public key of the certificate authority to make sure that it can unlock the box that it's getting back from the server. If it can unlock this box, verify the domain, and get the public key out, then it feels trust to encrypt the data with the public key that it needs to set up the session and send it encrypted to the server. We're using this public key. And again, once any data that this client sends, it encrypts with this public key. The only person that's going to be able to read it is that server on the other side. Now, I keep saying session over and over, and there can be sessions at multiple levels. The key thing to remember here is that the client and the server are exchanging data to establish an encrypted connection. And so when I'm saying session here, what I'm talking about is that encrypted conversation between the client and the server. You'll also typically with HTTPS establish a session at a higher level, another session which is your application level session, which will have other information in it. But this lower level secure communication is based on this idea of public-private keys, and the fact that if I have a private key, I can prove my identity by putting some information into a box that only you can unlock with my public key. So if you have my public key, you can verify that information came from me by seeing if you can unlock the box with my public key. Similarly, you can hand off information to me by putting it in the box and locking it with my public key, because you know only I can unlock that box with my private key. And so using a series of these box analogies of locking data into a box with a private key and unlocking it with a public key and locking it in with a public key and private key, and adding this idea of a certificate authority that we already trust and establish some key relationships with on our clients, we can dynamically set up and trust our encrypted communications. Now, unfortunately, sometimes there are errors in how these things are implemented, as we've seen from some recent vulnerabilities that have been discovered in things like OpenSSL. But the fundamental idea for this is a sound approach for using encryption and special relationships between these keys to securely establish a conversation between the client and server that nobody else can sit in the middle of and intercept data for. When do we want to use HTTPS, or the secure variant, instead of HTTP? Well, one way of thinking about this is we can divide our data into two buckets. The first bucket is data that's for everyone. There's no restrictions on it. This is the free data zone where anything that we put into this box, we assume that anybody else can read. So anything in the everyone category, anyone can read. And anything that we put in the everyone category, if we accept a post request or a put request or a delete request or any of those things, then potentially anyone can write. So if we accept those other types of requests like put, post, delete, then anybody can write them too. Now, the second bin of data that we're going to talk about is we're going to call the restricted. So if there's even a single person who shouldn't have either read or write access to all of the data in here, then we need to put it in the restricted box. So, is there any client that shouldn't read, write all of the data? Anytime that we answer yes to this question, if there is a single client that shouldn't have access to all the data or shouldn't have access to write all of the data, then more than likely we want to use HTTPS. So we think of this as HTTPS communication, and we think of this as HTTP communication. So anything that we are doing that is for everybody, we're not trying to hide anything, we're not trying to restrict anything, then HTTP probably makes more sense. If there's any restriction in any way, let's say some of this data is owned by one person and some of it is owned by another person and they shouldn't have access to each other's data, then HTTPS makes sense. Or some of the data is public and I can get to it, but other parts of the data are private and only the administrator can get to them. That it sort of implies that we're going to have HTTPS. Anytime we have something that isn't for everyone, anytime we have operations that aren't for everyone, so maybe all of our data can be read, but only some of it can be written to, like with put, post, or delete, and who can write to it changes based on what data it is. Or certain people can write to all of the data, but others can't. Anytime we have these restrictions on the data, and we have two buckets, the bucket for data for everyone and the bucket that's restricted. Anytime we have the restricted bucket, anytime we don't want everyone to have read access, or if we're writing data, every time we don't want everyone to have write access, then we need to switch over and use HTTPS. If you're serving up email, you should be over a web browser, you want to use HTTPS. If you're returning the person's private contact details, you want to use HTTPS. If you're returning the weather in a particular region, you're going to use HTTP because that's public data, nobody cares. So this is how you want to think about when you're building your clients, whether or not to use HTTPS or HTTP. Do you want anybody to have access to all of the data? And if you are allowing data to be written to, do you want anyone to be able to write to all of the data? If the answer is no to any of those questions, then HTTPS should be involved somewhere in your communication with the server.